So I would now discuss few more problems on logarithmic decrement and relaxation time. So let us take down the problem number 4. Problem number 4. Well, the frequency of an undamped harmonic oscillator is adjusted to be equal to half the frequency experienced by the oscillator without damping. I repeat, I am not going to write down the problem. It takes a lot of time. The frequency of an undamped harmonic oscillator is adjusted to be equal to half the frequency experienced by the oscillator without damping. You have to calculate the log decrement. So, let the frequency of the harmonic oscillator without damping, let omega 0 be the natural frequency. The frequency of the harmonic oscillator without damping. Okay. And the frequency of the damped oscillator, okay, frequency of damped oscillator. Alright, frequency of damped oscillator. Well, now what is the relationship? As you know, omega prime is equal to square root of omega 0 square minus k square. What is k? K is the damping coefficient. Now, what will be half of omega 0? Half of omega 0, yes, or so you see, because as per the problem, you see, it is actually the frequency of the undamped harmonic oscillator is adjusted to be equal to half the frequency experienced by the oscillator without damping. So what does that mean? Omega 0 by 2 is half the frequency without damping. So if we say this as equal to omega 0 square minus k square. Okay, so it is this realization which is important from your problem. This is something which you should be able to write. The rest of it is simple trigonometry. Because if you look into the problem, the first thing that they are saying that the frequency of an undamped oscillator is adjusted to be equal to half the frequency experienced by the oscillator. Sorry, the frequency of the damped oscillator is adjusted to be equal to half the frequency experienced by the oscillator without damping. So this is what you need to write down first. So then other things follow. Other things follow as simple mathematics. How? You see. So if you keep it here, you see what you get from here. Omega 0 so if you take the squares, what you get is omega 0 square by 4 is equal to omega 0 square by 4 is equal to what? It is equal to omega 0 square minus k square. So from here you can get k square equal to 3 by 4 omega 0 square. So what do you get k from here? K will be equal to square root of 3 by 2 omega 0. Alright. So that is equal to how much? Root 3 times omega prime, isn't it? Now what is your log decrement lambda? The log decrement lambda is your logarithmic decrement, isn't it? That is equal to how much? KT. Okay, so you see, and what is T equal to? You know T is equal to 2 pi by omega prime. Okay, alright. So what can you say over here of lambda? Lambda is equal to root 3 omega prime into 2 pi by omega prime. If you just make simple substitutions, it is 2 pi root 3. This is what you would be getting for your log decrement. Okay, so another question, another problem on the relaxation time, just problem 5. Okay, this problem I would like to take as test for you all. Okay, a damped vibrating system starting from rest reaches a first amplitude of 500 millimeter. So its first amplitude, okay, so A1 will be equal to 500 millimeter. I repeat, a damped vibrating system starting from rest reaches a first amplitude of 500 millimeter, which reduces to 50 millimeter in that direction after 100 oscillations. After 100 oscillations, it reduces to 50 millimeter. Okay, so this will be equal to 50 millimeters. All right. Okay, so you see, therefore now they are saying that it reduces to 50 millimeter in that direction after 100 oscillations, each of period 2.3 seconds. So the period they are giving t as 2.3 seconds. Okay, you have to find 1, the damping constant, okay, 2, relaxation time, you have to find the damping constant, relaxation time, and you have to find the correction for the first displacement for damping. Correction for the first displacement. For damping. Okay, I will give you the hints so that you can get the answers. So you see, the damping constant K is given by what? It's given by the relation. If you remember, since we have studied log decrement, well, ln A1 by A2 is equal to ln A2 by A3 is equal to K. Okay, this is equal to KT. So these are the ratios of the successive amplitudes. So the amplitude of n vibration after the first n plus 1th vibration is a n plus 1, isn't it? So that will go as nkt. Okay, now you have A1, you have A101, isn't it? So, well, and you have n also. N is equal to how much? 100 after 100 oscillations. So, basically, therefore, you see, if you kind of do log of an plus 1 by an, it is equal to nkt. So from there you can find the value for k, and once you get the value for k, you can get the value for tr. So from here you can get the value for k, from k you can get the value for tr. Okay, now you know how you get the value for lambda. Once you get the value for K and TR, you can get the value for, you know how to get the value for lambda. You know the amplitude A0, how you will obtain if the damping force was absent. What is the corresponding formula? So what should be the correction for the first displacement? You subtract and find out. Let me see, you can proceed, and if you get stuck up, I will help you out. Okay, all right, let's stop over here.